In this video, we're going to be going over complex numbers on the complex plane in polar form. So, a complex number in rectangular standard form is z is equal to a plus b times I. A is real and is your horizontal dilation. B, or direction. B is your imaginary part and is your vertical direction / axis. And on the complex plane, a point is A, B. So you can treat X as A and Y as B. So we have real and imaginary in the complex plane. Now, the goal of polar form is that it's going to describe a point as well, but it's going to use r, which is the distance from 0, 0 pole origin, and theta is the angle from positive real axis. That's referring to this positive real axis. That's where you start measuring your angle. So key relationships is r is equal to the root of x squared plus y squared. Cosine theta is equal to x over r. Sine theta is equal to y over r. X is equal to r cosine of theta. Y is equal to r sine of theta. Now, to get the polar form of a complex number, you start with z is equal to x plus y1. You substitute x with r cosine theta, and here you substitute y with r sine of theta. So then you're left with this. Now we see we have an r, so we can actually factor that out, and we're left with cosine theta plus I sine theta for z. Now this is in our polar form. Now, in order to find theta, our formula is tan theta is equal to y over x. So then, in order to get theta by itself, you have tan negative 1 y over x. However, tan negative 1 can give wrong quadrant. And that's because of its range restriction. Therefore, you must use signs of x and y. So if x is positive, that means that theta tan negative 1 y over x works directly. Therefore, Q1 or Q4. But if x is less than 0, that means you have to add pi to get your correct direction. That's when it lands in Q2 or Q3. Now, Let's say we have two problems. For first problem, we want to plot the point z equal to -3 plus the root of 3i in the complex form and write an expression for z in the polar. First, we want to identify x and y. So x and this is y. So going left on the real axis, and then we're going to go √3 on the imaginary axis. So now we have to find r. Now we have to find the reference angle for this is going to be pi/6. For positive √3/3. So for this, it's going to be -pi/6. Now you have to fix the quadrant because you have a negative x and you have a positive y. This is Q2. Now in Q2, angles are so then you have theta minus is equal to pi minus pi/6 is equal to 5 pi/6. So now you write your polar form. X is equal to 2√3 cosine of 5 pi/6 plus I sine 5 pi/6. Now you can solve this step by step. So you can distribute. Oh, actually, this is fine. So if we were to graph this for number 1, our point it would be somewhere over here. A little bit higher than that for Now, for our second question. We need x and y. But actually here, what we can do first is we distribute our 2. So we have now we can evaluate this. 11 pi over 6. Pi over 6 is 30. 11 times 30 is going to be 300. Now 300 is going to be 60 away from here. That's going to be 30 away, so it's going to be like this. 300 is going to be there, and this is going to be a reference of 30 degrees, and 30 degrees is root 3 over 2 1/2, and we're looking at cosine, so that's going to be root 3 over 2, but 300 degrees is in Q4, and here in Q4 you have a positive x and a negative y, so we're looking at x, so it's going to be positive root 3 over 2. Those 2's cancel, it's root 3. Now for 2, we're looking at sine, and we're looking at the y. So then you're looking at 1/2. It's going to be negative 1/2 because it's going to be a negative y in this coordinate, in this quadrant. So that's going to be equal to, or you could also write this as 2 times negative sine of pi over 6 if you wanted to, but if you consider it this way, that is just that coordinate. So that would be 2 times negative 1/2, which equals to negative 1. Now, you write in the rectangular form. For our first question, we are going to convert from rectangular to polar form. So we have z is equal to negative 2 root 3i. First, we identify our x and our y. Negative 2 is our x, and negative 2 root 3 is going to be our y. So we know that x is going to be negative and y is going to be negative. So that means that you are going to be in Q3. So now we're going to find our r. R is equal to x squared plus y squared. Now our theta ref is equal to pi over 3 because of the fact that we have to find theta, and we got theta from because we know at pi over 3 you have, and then when you do tan it's also equal to sine theta over cosine theta, and that is going to be root 3 over 2 over 1/2. So those canceled out. So now, because you're in Q3, you have to adjust. So theta is equal to pi plus pi over 3, which is equal to 3 pi over 3 plus pi over 3, which is 4 pi over 3. Now you have to, let's actually move these questions down so you have more room. Write in polar form. You can write this as z is equal to 4 cosine 4 pi over 3 plus I sine 4 pi over 3. Plot the corresponding point to z is equal to 1 minus the root of 3i. This is going to be your x. This is going to be your y. Q4, because you have a positive x, but you have a negative y. Now we have to find r. Let's move these over. Just like we did earlier. Now, theta ref is equals to pi over 3 because tan pi over 3, as we've seen earlier, is equal to root 3 because of the fact that it's root 3 over 2 over 1/2. So that means that it's in Q4. You have to adjust for this. That means that theta is equal to 2 pi minus pi over 3 from the reference angle, which is 5 pi over 3. Now in polar, now let's do question 3. Write z is equal to 4 cosine 5 pi over 3 plus I sine 5 pi over 3 in rectangular form. We know that x is equal to r cosine of theta, y is equal to r sine of theta. So you have 4 cosine 5 pi over 3, and that's going to be 4 1/2, that's going to equal to 2. And then you're going to have 4 sine 5 pi over 3, that's going to be 4 times negative root 3 divided by 2, that's going to be negative 2 times root 3. And then that's going to give you this point, z is equal to 2 minus 2 root 3i. Now, on to our last example. Write z equals 4 cosine 5 pi over 3 plus I sine 5 pi over 3 in rectangular form. So again, this is going to be negative root 2 over 2 Now let's do one more problem. So characteristics of Q2. Now it's going to have been so we know